seeing something amazing and fantastical from a book or a film or comic and then going, can that be real? And how do you bring that into our world and be practical and useful? I started to ask the question, is the retina a keypad to the brain? Is there like a gentle way to access the visual cortex? When we started the company, I had MIT, Caltech PhDs said, you'd never make pixel stick work. You'd never make this work. You'd never make that work. Every single thing they said would not work, we made work.
I'm your host, Jon Hirschtick. I've spent my entire life building CAD systems, but the best part of my job is I get to meet some of the coolest engineers and designers in the world. And in my podcast, you get to meet them too. So very exciting today. My guest is Rony Abovitz. He is currently the founder and CEO of Sun and Thunder, but he also was the founder of Magic Leap and the founder of Mako Surgical. And he's also currently a senior advisor to Boston Consulting Group. And he's also a longtime friend of mine and an all-around fantastic guy. Rony, welcome to the podcast.
Thank you, John. It's great to be here, and thanks for having me on.
Well, I know everyone's going to love hearing from you. So many things to talk about. I mean, you and I could talk. I do 10 episodes with you, Rony. But I want to jump right into Magic Leap because that's, a lot of people have know you for Magic Leap. I mean, you've been on the cover of Wired magazine, right?
Yep.
Yeah. What was that like being on the cover of Wired magazine for a moment?
Totally and utterly insane. It was out of body. It was out of body. I didn't even understand what was happening.
Really? Well, yeah, like you probably weren't thinking about that when you started like designing products and starting companies and things, but
no, not at all. Not at all.
It was very cool. And you're so modest. You didn't even tell me about it. I learned about it by seeing you on the cover of Wired magazine. I'm like, oh, that's cool. That's Rony, my friend,
I didn't really say that to anyone. My sister, she was at an airport. She sends me a picture. She's like, what are you doing on the cover of Wired? I'm like, I don't know. I don't understand what's happening right now.
So Magic Leap, I also remember, I have to ask you about a couple of cool things. You probably have 1,000 cool stories of Magic Leap, but can I ask you about the story? Didn't the founders of Google, the Google guys, fly in on their plane and meet you at Magic Leap in the early days?
They did, and the parts I can talk about are I was the first angel investor into Magic Leap, and I was able to put some money in because I founded Mako Surgical. We went public, then Stryker bought us. My wife actually was smart. We put most of the money away so that we would be set and can't touch that part. But we put some into the next thing, right? So I'm like a finite amount to angel invest into it. And then the next investor was a guy named Scott Hassan. Now, Scott is one of the quiet co-founders of Google. If you read the history of Google, he pops up a lot. I almost think of him as the Paul Allen, what Paul Allen was to Bill Gates. Like Scott was there at the beginning. He actually introduced Larry and Sergey together. And Scott wrote a lot of the code on the search engine. Yeah, he's one of the great coders of all time. Total genius coder. And he had started a company, actually an interesting, like an institute right by Stanford called Willow Garage, where he was creating open source robotics. He was creating this operating system called ROS, all these cool open source robots. There's a whole history of Willow Garage. Lots of cool spin outs came from it. And he was just funding them because, if you're a founder of Google and you got founder shares, he didn't stay in the company that long, but he got the founder shares because he played such a critical role in giving birth to the search engine. And when you actually asked Larry and Sergey and Scott all about the founding Google, I heard the same story from all three of them at the same time one time over dinner. It was kind of amazing. So that was really incredible. But anyway,
dinner with all three of them.
So I heard the story from each separately, but then one opportunity I had all at the same time. And it was truly incredible. And Scott's a special genius type human being. They're all geniuses, but like those three, the speed at which they created the company and invented what became one of the biggest companies in the world, like in a garage, is just truly astounding, especially when you hear it right from their horse's mouth. So Scott became the second investor in Magic Leap. And there's a whole story about that. I don't know if we want to get into it, but I was the first angel. He came in and was incredibly helpful because he said, look, you got to incubate this. I'm going to give you space and time to do it in a way that no venture fund ever would. And I actually had some great venture funds. We were on the way to dinner to close a term sheet, but I hadn't signed yet, with a venture fund when I met Scott. It's a whole story that'll take up this whole podcast, which we don't do today.
Well,
and then Scott basically gravitationally pulled me away from that. We hung out till late in the night, and then it was just like talking about Mars and all kinds of crazy things. And he said, look, I want to fund this. And he became like the first like real investor after me. He sort of made it come to life. And you got to understand, like, they were friends. Scott and Larry and Sergey were friends from before any of them had made any money. And I think there's a difference between being friends with someone before you have anything, because you know that friendship's genuine.
Mm-hmm.
And I think there's something like after you've done very well, everyone's trying to be your friend. All these relatives come out of the woodwork. But I think because they were all together in the garage, it's like a kinship, you know, like the Beatles in Hamburg kind of feeling.
Mm-hmm.
And, you know, so the fact that Scott was believing in what we were doing and giving us the ability to take this moonshot. If you go back to when we got funded, it was like the era of like the Larry Page moonshots, where he was talking about changing the world in a big way. He was the CEO of the company. He kind of took over, and Eric Schmidt became chairman. And it was like this sort of renaissance of the original ideas of Google. Do really big, change the universe kind of things.
So can I ask, so they also flew out on their jet, right? And came to visit you. And
so the short version of it, it's actually a really great story, but
yeah, let's hear it.
There's a lot of back and forth about me bringing what we had to them. And I'm like, it's basically taking up a whole room. And it was like, well, we can get you a cargo plane. And I'm like, look, we made this one thing. It's really delicate. It's working. I cannot fly. And it was like this, like weeks, I think a few months actually of like, like literally them being frustrated. And they're like, why can't you fly this to us? Like, we'll send you a C-130 or something. And I'm like, I just can't. So finally, I think Scott intervenes with them. They're like, all right, we're going to come over. And like, I think they showed up early in the morning, so they flew all night. And I just get this call the day before. I remember telling like our small team at the time, like, oh my God, Larry and Sergey are coming. And like, we really got it. Like, everyone's like, oh my God, it's like, what's going on? Because we had just like left my garage and we were in this like little warehousey thing. If you remember,
I remember
the very first place we were at. It was like a strip mall kind of thing.
Yeah, I remember it was a strip mall place, and I remember coming to see what I assume was very similar. And I want to get to that in a moment, but I don't want to get too far off from the story of the Google guys and raising billions of dollars, which isn't the main story today. It's a story because everyone who builds products, very few people can get a product to market on their own resources. Everyone's raising money or support from someone. Sometimes it's venture capital. Sometimes it's getting your vendors to jump in. Sometimes it's getting friends. So everyone's selling ideas to someone. Now you happen to sell it to some of the most interesting someones in the world. And you raised, just so they flew out. And ultimately, how much money did you raise for Magic Leap? Let's get to that point.
We raised over $3 billion.
Okay.
Over $3 billion. But I want to put it in
$3 billion.
Over $3 billion. But I want to put it in context because in 2022, now you could look back a little bit and you see what like Facebook, which now renamed itself Meta after the metaverse.
Yeah.
If you look back at what they spent last year on the same topic, on like XR, their AR VR program and metaverse, it was over $12 billion in 1 year.
Really?
So they spend in one quarter what we spent in a decade. Now, if you actually go back to when we started, remember Facebook acquired Oculus actually a little bit before we got funded by Google, I think around the same year. So if you think about that and you can calculate how much money they've been spending, my estimate is somewhere between 35 and 55 billion by Facebook alone to do what we were doing. So people ask me, oh my God, 3 billion is a ton of money. It is enormous amount for a startup. I had no idea. that we would actually need to raise that much. But when you look at what Apple is spending and Facebook is spending, all accounts that I've got are that Apple's outspending Facebook. And if you consider in the same time period, Facebook has probably spent 35 to 55 billion to do what we're doing. And Apple is probably more than that. You're talking about just between those two companies, you're approaching 60, 70 billion just to build the technology and make it work and begin to make the early market work. So our 3 billion is dwarfed by our competitors by 10x, by 20x. I mean, one of the things I use to give people a sense of context, they spend every 3 months what we spent in a decade. So as big a number as it sounds, I don't know why I did this. I decided to take on the biggest companies in the world in computing to try to change computing.
You know, amazing. Actually, it's such a great point, because I'm really here to draw out your thoughts, but I can't resist injecting one of mine, because in my own world, I've done at my scale, in a sense, similar things. People thought it was crazy to build new CAD systems, and you have to be a little nuts to do it. But I always say, when I look at startups, I always say to people about raising money, like, oh, that's a lot of money. I don't want to spend too much money. And I always say, nobody wants to spend too much money or too little money. The question is, what's the right amount to invest? You know, in my gambling career, we would look at how much do you put in a betting circle in a certain situation? What's the right amount? And numbers like big, small, you know, those are relative terms. We learn in school, you know, in physics, you learn that big, small, slow, fast, hot, cold, those are all relative terms. Big relative to what? Well, relative to other startups, maybe. The question is, I always say on boards when I'm involved, what's the right investment for this opportunity?
But John, since you brought it up, we had, before the large Google investment, we had a fairly small amount of capital in.
Yeah.
And right before the Google investment, we had an offer to acquire the company for close to 2 billion. Now, if you go back to your MIT 21 days, if we could go on a time, you would have said, you have just maximized time, small capital input. It probably will not get better than that, because the next road is very hard, right? You're turning down an offer from a giant competitor who could outspend you 30 to 1. And you might ask, well, why did you do that? Now, my wife will probably never forgive me for that one. But there probably are, I think for anyone who's an entrepreneur, there's these moments early on.
Yes.
Where you might have that kind of opportunity, and your time, you know, investment ratio is probably never better than that early moment someone wants to get you, because you've solved some fundamental thing and they're like, we don't need you to do the rest of it. We could do all the rest of it. So that was probably that was one of the moments, like if you go back to your 21 days, that we probably should have walked off the table.
You think
because
so?
we had, well, on a financial level, yes. On a personal journey, education, changing computing level, no.
So does any, there you, I'm sorry, go ahead.
No, it would have been financially, yes. But if I did it for financial reasons, I probably wouldn't be an engineer.
That was going to be my next point is, does anybody develop great products strictly for money? Now, you know, yes, you want to make money. I mean, it's clear you want to make money, you're interested in order to marshal a business around you. And not all product development efforts are businesses, but no one does it just, if all you wanted to do was make money, you might be a senior advisor at Boston Consulting Group, like you are now. I'm sorry, I joke you. No offense to my friends at Boston Consulting Group, but you know, like you can make more money on Wall Street or something. But you're this product developer, and it's always struck me that you've had amazing vision. And so for you, though, you happen to raise more venture capital than almost any startup I've known of that's making a hardware product. But you really raised, what you're saying is you raised the right amount to efficiently pursue, relative to competition, a very large vision. Let's talk about the vision. Tell me, you had a vision for Magic Leap. What was that vision at the beginning? What drove you to start Magic Leap?
Yeah, so That's a great question. I'll try to condense it into our time. By the way, be happy to do a part 2 with you, because like you and I can go on for like 10 hours. But
yeah, well, let's assume we do one episode just on Magic Leap, and we can do one episode. I don't know, just keep going, and we'll edit it down. We'll make it digestible for my listeners.
But I think, like you, John, I always believe in having a clear vision about what the world could be. And in this case, it was like trying to reimagine fundamentally computing. Now, a little bit of background. I grew up with computing. Like I'm a kid where computing always existed. Like I was a little kid beating all the adults in Pong and Atari and video games. I was programming when I was like 5 or 6, So wow. I just sort of grew up with the idea that computing was in my world. And when I was a kid, my dad got me the first 128K Mac. So that was incredible. And it was like I sort of, going from like the early computers were like, black and green screen and like a TI 99 4A to the 128K Mac was this revelation, because it was like, wait a minute, this computer is trying to be friendly to me. It's trying to approach the human. And that never left my mind, right? So if you think about like that stuck in there. And that happened around the same time where I was like a massive like Star Wars fan. So I'm like, seeing this world imagined by Lucas, where like droids, unlike in 2001, which trying to kill people, droids were actually, some of them, like R2 and 3PO, were like helpful. They were living amongst people. And then I get this Mac, and I'm like simultaneously going, this world and the movie world and this world of computing, they feel like they are coming together in some way. So I first tried to do something about it with Mako Surgical, where literally we built a droid for surgery, which was deeply inspired by the medical droids in Star Wars. It was like literally, cool. And one of the best moments of my life was George Lucas visited us at Magic Leap, and I told him one of the things I did in my life was I built a surgical robot company building the medical droids inspired by you in Star Wars. And then I think Magic Leap was partially inspired by, like Chewie playing holographic chess in the Millennium Falcon. And I'm like, wait a minute, you have like completely shaped my life. What is going on here? He's like, dude, you need to get a life.
Dude, you need to get a, that's what George Lucas. So George Lucas.
It's like, wait a minute, like I just made movies. You chose to take the things I made from and like decide to actually make them real. And I think that's a inspiration point. Like seeing something amazing and fantastical from a book or a film or comic, and then going, can that be real? And how do you bring that into our world? Not one-to-one, but make it so that it could fit into our world and be practical and useful. So I think I've reversed engineered things from movies and books probably my whole life.
That's just amazing. But I can't you just kind of casually mentioned, and when, George Lucas came to visit, come on, man. That was like one of the best days ever. I have to say this. I put everyone on Star Wars prohibition, meaning from the moment he stepped into the building to the moment he left, no one could bring up Star Wars. We could talk about THX. We could talk about all like THX 1138. THX 1138. Not that I'm a fan or anything. I'm just
I talked a lot about Red Tails, which is a film he produced, which is about the Tuskegee Airmen. It was like a all black fighter pilots. One of my favorite movies. Okay. But and at the end of the day, he's like, "Do you know I made this movie?" I said, "It was about space, maybe spaceships or something." He's like, literally nobody in this building knows who I am. I'm like, no. I put them all on. Yeah. If you mention Star Wars, you're going to be fired, because I figured you don't want to hear about that from us. He's like, I actually really appreciate it. We just
That's really cool.
He just thought he was another guy in the building, just an engineer. No one was going to bother him, even though everyone was going completely nuts and they wanted to know everything. I'm like, nobody could say a single word about Star Wars. He could talk about
that is so
THX 1138. Yeah, it made him feel comfortable.
I mean, anyone would be interested in meeting. I think most anyone in society would be very interested in meeting George Lucas, of course. But as a product developer, I think, the kind of people that we work with are engineers, product developers, product designers, I think are especially interested for so many reasons that are sort of obvious. But then to hear that he came to visit you shows such interest. By the way, the thing you said about no Star Wars, It's funny. I'm not going to, again, not to talk too much about my own life, but I happen to know a father of a fairly famous athlete. And whenever I get together, we're just kind of friends. I try really hard to not talk anymore about his child who's an athlete versus his other children who are adults and doing other things in life and his own business or whatever. Because I figure, I don't know. I just think it's just the right thing to do. But I have not met George Lucas. That's extremely cool. Rony, just drill down into George Lucas. I know a couple other things. It's not only that George Lucas came to see you, but you also, can you talk about your travels to certain places involved in George Lucas's world or not?
It's public. We did a partnership with Lucasfilm,
which
was incredible, and that was just absolutely incredible. But wait, before we go there, let me finish your product question. So I think there's sort of threads that lead into it, but I'll tell you the key moment of inspiration for starting Magic Leap was walking on the beach, looking around where you have this like very widescreen field of view. Like you just see the ocean. Everything is amazing, super high fidelity, ultra HD television. And I'm like, there's no screen here. There's no screen, but the display is amazing. I'm just wandering around the beach thinking about that, going, I've got the world's best head-mounted display in my head already. I just kept thinking, that sounds so obvious and stupid. But wait a minute, is it obvious and stupid? Like, why are we sticking displays in front of our eyes when we have the best display in the world in our head and it's already head-mounted? So I started to ask that question. Like, we have the best head-mounted display. And I'm like, and I'm a biomedical engineer. I'm like, the visual cortex is an amazing display. Why aren't we using that? Like, this is so dumb to try to build displays outside our visual cortex. And we have the world's best display. Everyone's got one. So I'm like, so I had these two thoughts, like, because I came from computer-assisted surgery. I'm like, do we have to jack in like the Matrix? Is that because, I actually, with Vanderbilt and other players, I'd been inside functional neurosurgery and deep brain stimulation, which people now call brain-computer interface. The very early days of Mako, we were involved in that, doing computer-assisted neurosurgery. Tumors, epilepsy, Parkinson's, tremors, seeing surgeons put under computer guidance electrodes in the brain and wire things in the brain for disease solution. And I'm like, well, that sounds like an awful thing to do. Like, I don't want to put millions of wires in my brain and make that a computer. By the way, people I won't mention on the West Coast think it's a grand idea to jack directly in. And some of them are putting billions of dollars into companies to do computer brain interfaces, not just for disease, but they think that's the way to go. So then I started to ask a different question. If you don't want to jack in directly, which I thought, like, intervening for a disease, for a tumor to save someone's life, to help someone with Parkinson's, dystonia, essential tremor, absolutely. That's a life-saving, life-changing kind of thing. But just to do that to a healthy person, I felt like that's wrong. So I'm like, well, how else can we talk to the visual cortex? So I did a whole bunch of like research into where are we in neurology? What's the state of the art neuroscience? Started talking to a lot of neurologists, neuroscientists. I started to ask the question, well, is the retina a keypad? Like, is the retina a keypad to the brain? Can you tap on it? Is there like a gentle way to access the visual cortex? That was a starting question. And I said, well, if you could do that non-invasively, if we could gently learn the programming language of the retina. I was literally using terms like this with the first engineers at Magic Leap. Like, wait a minute, the retina might have a programming language. The visual cortex is like a GPU and is surrounded by C. Is there like a CUDA language here? Like, can we learn that? Can we talk to it? Can we do it in a way that's non-destructive, and a way that would be very biomimetic and gentle? By the way, that was asking an incredibly difficult question that no one's really answered yet. And I think we started to answer at Magic Leap in some profound and fundamental ways. And then there was like a fork where it's like, are we making a shippable product, or are we just going to be a research institute? By the way, there was a place where we could have said, we're just going to be like a fundamental neurocomputing research institute and spend all of our time answering that question. And it would probably still be today. We've never shipped anything at all, but we would be deeper in answering that question. Because the beginning of it, and this was like, I think Scott's amazing help, he allowed us to float around that and to really attack that question and to go after it. And by the way, we started to go into some amazing understandings of that. We started to work with like brilliant neurologists, neurosurgeons, ophthalmologists, neuro-ophthalmologists, people from Harvard, people from all over the world. And it was really an amazing time of just pure research. And I was like feeling incredible that Scott was allowing us to have this space like a research to discover things about the interaction between physics and the brain. By the way, that was such an exciting time. All of us were like so excited about every day was like a new discovery.
Well, you're lucky to have the right partners to support you in that, you know.
But here's the thing. You're a product person. I'm also a product person. And I realized we were going down a road of like fundamental science and physics and neurology. And we could probably have been in that tunnel for 20, 30 years and never ship anything. But have made all these fundamental papers and discoveries and research. And part of me is like, maybe that would have been kind of awesome to do. But the other part was like, if we want to move society to a new kind of computing, how do we take the early things we're learning and reduce it to wearable form factors and something that could be shipped and something that could actually move people away from the laptop, the iPad, you know, tablets and phones into the next thing of computing. And I feel if you look at the amount of activity and the biggest players in the world all now following our lead, like they're all going down that direction. I feel like we probably did set off an avalanche in that direction.
You did. And not, you know, I have to say that I look at what you've done and it's amazing to me having known you. By the way, just for our audience, you know, I first met Rony in the early days of not Magic Leap, but Mako, his company before Magic Leap. I also remember, I can't help but add here that when you were trying to start Magic Leap and you sent me some documents and I called you back, I said, Rony, I can't understand what you're talking about. This doesn't make sense. But you clearly knew better. And also, can I just ask one little element there, and I want to move on, but one more element, wasn't part of your drive for Magic Leap based on your vision of content that you were trying to imagine and storytelling? Is that true? Do I remember that correctly?
Absolutely. Yeah. So if you go, what drove me to thinking about the brain as a display?
I even remember the name of it, by the way. I'm not going to say it unless you do, but go ahead. I'm sorry.
Yeah. So by the way, I started a project called The Hour Blue.
The Hour Blue. That's what I remember. I wasn't going to say it.
H-O-U-R Blue. Yeah. B-L-U-E. And in fact, I when we got funded at Magic Leap, I actually separated Hour Blue out, because it became like a creative mythopia project, like a whole mythology, like a Tolkien, C.S. Lewis kind of.
Okay.
So basically, if I go back, what really triggered it was I became really interested while I'm doing Mako in mythopias. And mythopia, the simplified way to describe mythopia is a story world. And the way to describe a story world is, think about a story as like one path through an imagined universe. But a story world is the higher order. Instead of the line through that higher order volume, it is the entire container of all the stories somewhere. So if you think about people talking about world building, this is a different kind of world building. The idea of mythopia is that authors, Tolkien was probably one of the best proponents of this, J.R. Tolkien, who wrote Lord of the Rings and The Hobbit. And he had this belief that he could imagine and create complete story worlds with many different legends and many stories and treat them as if these had really happened. And he created this whole backdrop of mythology and characters and like almost religions and all sorts of things in them. So they felt so real. And when he would write a particular story, he'd be referencing all of the other facets in his mythopia. It's kind of different from an author writing, here's a story about, like, Hemingway catching a fish in the sea. I mean, great novels, but what Tolkien did was, like, he tried to create like think about like a plane, and you're leveling it up to be like a cube. It's a higher dimensional space.
Yeah, no, I get it. Well, wouldn't you say, isn't Star Wars one of those too? The
Star Wars
world
is absolutely inspired by people like Tolkien and mythology. In fact, deeply inspired by Joseph Campbell, who wrote The Hero's Journey, and talks a lot about mythology and mythopia. So Lucas was a big disciple of Campbell. So I started to read a lot of Campbell. I'm reading tons of Tolkien and C.S. Lewis, and I'm thinking they're not just typical writers. What they're doing is they're creating this whole like higher dimensional, n-dimensional story worlds. And I was like very fascinated with that. I'm like, what's going on there? And I started to ask a question: what if that intersected with technology?
That's what I want to get to. So you didn't say, well, I'll write a book like like Tolkien, or make a movie like Lucas. You said something else. Why? How do you get from thinking about those mythopias, learned a new word there, how does that bring you to more drive for Magic Leap?
So I was asking the question: how could you contain a mythopia in something? Like film, which was developed in the late 1800s, is a good container for a single thread of a story from a book, which becomes a script. But when you think about this like n-dimensional mythopia world, you're like, how do films contain them? So then you watch all the, like what Lucasfilm was doing. He was trying to create worlds that had to down reduce them into his 2D films.
Okay.
And then Weta Workshop, the one that really got me going was Weta Workshop and Weta down in New Zealand, where they brought Tolkien to life with Lord of the Rings and The Hobbit. And then they worked with James Cameron and they brought Avatar to life. Now, I'm like, okay, I think what's going on in New Zealand, these people are students of mythopias, and they're creating physical, digital manifestations of worlds, still only landing on 2D, but they're thinking much bigger. Like everything I'm hearing about what's going on at Weta is like they've got much bigger thoughts. I'm like, I kind of need to meet Weta, which was a ridiculous thought, right? Like, so I reached out to the head of the Weta Workshop studio department. I just called and emailed and didn't hear back for a few weeks. And I said, I'm building robots. I was, this is what I was doing at Mako. And my night was trying to figure out what I'm doing next. Mako already had gone public and we were close to getting acquired. So I get back an email from one of the studio managers at Weta. And it's like, a friend of robots is a friend of Weta. We'd love to hear about what you're thinking. And I still have that email. It's amazing. And then I got introduced to now one of my best friends, but he was a founding board member of Magic Leap, a guy named Sir Richard Taylor, who's won like 5 or 6 Academy Awards. And he co-founded with Peter Jackson all of the Weta stuff. Peter, his partner, Fran, and Richard and his partner Tanya, the 4 of them created all of the Weta companies that did The Hobbit, Lord of the Rings, Avatar, King Kong, all these things. They're just an incredible, in the middle of nowhere. Like, I'm like, what is going on in this tiny island near the South Pole that they have become students of Tolkien and this world building thing, and they get it. What are they doing on the other side of the world? And even better, John, they start to want to work with me.
Yeah, that's very cool. Yeah, so they start working with you. So let me get back to the technology. So when I first started to understand what you were building, you get going on building the concept of the what I'll call Magic Leap 1. Is that fair to say? Like the vision of before that, there were other devices, right? But when I first came to visit you, you told me all the problems you were working on, and I'm like, this is 10 startups worth of tech problems. Could you get into like the technology gamut that you were trying to solve and build?
So let me connect the dots pretty quickly. So in parallel, I'm working on like mythopian world building concepts with Weta. Okay. At the same time, I meet Sam, who's a brilliant rocket scientist from NASA. Yeah. I have a friend from Caltech who's a theoretical physicist who's helping and joining in, and another guy, Randall, who was like a brilliant computer scientist, was working at like a DoD computer graphics center and had been an engineer for us at Mako. So it's kind of a really small group. And then I meet Brian Schoengert, who's a neuroscience optics whiz professor from the University of Washington. So we have this little band, and I've got one part of my brain working with Weta, like the creative part, and the other part of my brain, the engineer, is working with this group at the same time in parallel. So what were we trying to solve with the science group was, could you talk to the visual cortex? Like, how the heck do we do that? And we built a machine I called the light field signal generator, or the Beast, because it was so big. And it took up most of a room. I think you got to see it once.
I did. I remember
put your head in this.
Yeah. It's like being at the eye doctor where you put your chin in a thing and you could only see through one eye and you look down a table, right? It's okay to talk about that. Yeah.
But the important thing about it was it had all kinds of knobs we can play with, and we got to play with many different parameters. And we built it so that we could understand what would a small, lightweight system need to be. There's a lot of things I can't talk about right now because they're still proprietary, magically trade secrets and stuff, so I'll leave that alone. But with that device, we could almost see many future generations of devices. But I also realized, okay, something that weighs hundreds of pounds is not going to fit on your head. That was obvious. But the other piece is, once you start to move around, you need computer vision. You need to track the eye. You need all kinds of sensing. You need all kinds of thermal and physics management. You need AI. You need a CPU. You need a GPU. I was like, oh my God, we're building like 10 computer things at the same time.
10 computer things at the same time, yeah.
Yes. I don't think people appreciate how insanely hard it is. Like, just the little pack that sits in your pocket that looks like a puck is the equivalent of like a high-end Alienware notebook or like a MacBook Pro folded down into something as powerful, but a tiny little thing that you could fit in your pocket, because a mobile phone processor was nowhere near strong enough to do what we needed. So the first generation, we had to stuff this super high-end NVIDIA chip and fold it up into the smallest form factor, but we needed that power. You don't want to lug around a big workstation or like around this, you don't want to walk around the big Alienware laptops. We had to fold this thing into this tiny little like Oreo cookie looking thing. People don't understand, like the engineering feat to do that is probably 2 startups. And most people don't even have any idea what that thing is, but it's like the battery management, the compression of computing to fit in there, the amount of compute power in that space, I thought was an engineering feat, and like most people didn't even care. Then we realized, at some point early on, I realized what we're really doing is a field called sensory field computing. This is the best way to talk about it. Sensory field computing, I think, I still believe it, is the wave of where computing and people fully intermesh. And what I mean by sensory field is the human sensory system is light field signal, sound field, tactile input field, smell and taste. So our brain processes these external inputs and builds a model and contributes to a model of the world that we have internally. So John, the best way to think about this kind of computing, think about a Waymo self-driving car driving around in Boston or something. It has a model of Boston. It has a map that's preloaded, but as it's driving around, it's adding, through computer vision and infrared and other things, it's adding more data. But its sight of the world is very sparse and limited. It's only to allow it to drive. It doesn't see the beautiful sunset. It doesn't see all the amazing things. It doesn't smell the food. It doesn't smell the great pizza in Boston. It's evolved, that Waymo's evolved to do what it's supposed to do. At some point, we realized that's what sensory field computing is. All of our senses filling up our brain. But we are no different from that self-driving car. That was like a profound, slightly sad moment, that the world we experience is not something we actually ever see outside. Now, this was like a weird leap for a lot of our engineers. You never, ever see the outside world. So if you think about that for a second, this was the profound magic leap.
What do you mean? Yeah.
You never see the outside world. You only experience a model your brain creates based on input that goes through a lot of layers of processing. There never is you ever seeing the outside world. There's only you inside, like a Plato's cave, building a model of the outside world. You never, ever, ever get to see the outside world. In the same way that car never sees the outside world. It only experiences a model of the world coming in through its sensors. It never sees the beauty of the outside world. And we're like, wait a minute, people are no different. We also never get to see that. We only experience a model-built world we created. Now, this was sad and profound at the same time, and this led to all of the thinking. The sad part is, oh my God, we never really get to see the outside world. But the profound part was, if you could understand how the brain wants to get each signal, and you could emulate it and make it biomimetic, you can actually talk to that model in the brain, and you can add digital content to that model. So we could gently use the CPU and GPU of the brain, instead of having to go in like the Matrix with like a cord and a bunch of wires. We can actually talk to it. That was like our conceptual thinking breakthrough.
So, all right. So you have this great vision. You start to dig into this mountain of tech problems. Also, actually, can I ask you also, there were a lot of other things besides the computing and the light field that would inject the image through the eye. Is that accurate to say that but you also were scanning? Is that right? Is that okay to talk about? You were looking around the world around you?
Well, I'll say this. Some things I can't talk about because they're Magic Leap IP trademark. But what I've said publicly is this, is that there's the mathematical construct of the physics of light fields. Now, if you look at the physics of light fields, they have been studied for like 100 years. There's a field holography, which captures the totality of a light field on a substrate, like one film, like one moment in time. But if you look at the amount of data in a light field, it's immense. And if you ask the evolutionary biology question about the human brain and how we propagated, how we survived, we don't need to process all of that information. In fact, we throw away lots of visual, sonic, tactile, smell information. We don't need all of that to survive. So we started to ask the question, what does the human sensory system need? What does it need to give us so that we can build a model to eat, craft, propagate, survive? And our theory was actually quite sparse data. This was like a conceptual breakthrough. And I've talked about this in public, that the idea that all you need is sparse data. By the way, that's still a controversial thing. There's still an entire school of people and engineers who think, no, you need to complete everything. You need the total physics. And these are physics, optic engineer folks. And there's this huge, interesting conflict between neuroscientists, biologists, who I think understand the brain does not need all of that information. And the brain actually does build its own perception. So what we found ourselves is at this intersection between evolutionary biology and neuroscience. What does the brain need to build the model of the world? And what do physicists want to do with optics and computing and constructing the complete light field? So there was this whole question about, like, if you don't need all of it, what do you need? Now, I can't talk about that middle part. That is the golden middle where this field ultimately will shine when you resolve all of that.
So I want to get to now where you've got an idea of what your first, probably going to fast forward a little. You got an idea of what your first product's going to be. The wearable headset compute pack with the controller that you would hold and a cable connecting, and this huge software world. I want to know, are you at that point in life, are you like, we're solving all these problems and the product's going to be built, it's going to be great? Or are you like, holy blank, what am I doing here? We're never going to solve all these problems? Because I think a lot of our audience would be in those situations where they may feel one way or the other. They may feel both ways within a day. I don't know. Like, how did you feel? Were you like, yeah, these are all going to get solved? Or was it like, this is impossible?
No, we did not think it was impossible. And I was really lucky to be surrounded by one of the smartest engineering groups, I think, at the time in the world. Hardware, software, systems. So I had this inner circle team of just everyone was like either brilliant genius or just expert craftsperson in their field.
So you were pretty confident.
Well, here, let me explain what we felt. We felt we were beginning to really understand the scope of the ultimate problem. Like, this is immense, and this is going to take a long time, like, to really, really nail it. But it's a little bit like being at Apple in 1970, going, what will it take to get to the iPhone today? Like, there's a huge mountain of computing. You begin to see the whole picture, and you realize this is a multi-decade journey. But did that stop anyone in computing from saying, no, we'll put out the Apple One, then the Apple II, and then the 128? The guys that put out the 128K Mac, of course, wanted a 50-inch screen at 4K resolution running at 240 frames per second. But they couldn't do that at the time. So they did what they could. But did they have bigger visions of computing? Absolutely. So my way of framing it to the team was, look, we're going to go Mercury, Gemini, Apollo. So the Magic Leap 1 was Mercury. We're going to down reduce today what we can shrink, miniaturize, ship, what we know that could be a glimpse at that future. And then the next one would be Gemini, which people now see as Magic Leap 2. And an Apollo, there was absolutely amazing stuff happening there just before the pandemic. And I can't talk about any of it, but like, we had this idea, and I think people on the team understood Mercury, Gemini, Apollo. I said that in public. I think one of the issues when you try to think about products as a series, aiming at a bigger vision, you have to repeat that over and over and over again, because
to let people know that. Yeah.
And by the way, our vision was, one day we're going to be an Apollo. One day all these amazing things will hit together. But in order to get there, we've got to take steps. And step one was Mercury. Now, I think some people confused Mercury for Apollo.
Yeah, yeah. So just back to, because there's a lot of our audience who builds and ships products and has some idea. I think one of the things that always struck me about you with Mako and Magic Leap, out on the side, is when I met you at Mako, and I want to get to Mako in a minute, but both companies were, in my opinion, among the most broad systems engineering, the largest systems engineering problems I had ever seen anyone attempt. And for me, as you know, in my business, I work with a lot of product developers who are building a lot of cool things, but your scope of system. But I want to get back to, so you ship, by the time you ship Magic Leap 1 and deliver it, and congratulations, by the way, on delivering, and now there's Magic Leap 2, but Magic Leap 1, I'm just curious, did you get it done? How did it compare to what your expectations might have been in time to ship, amount of investment it took, and the resulting Mercury level product? I'm just like, this is something we all product developers wrestle with. And I'm wondering, did you like hit the mark? Did you hit that, like the shuttle landed on the mark on the runway? Or was it like, gee, it was done twice as fast or twice as long? Or I thought Mercury would be more or less, or spent more or less money. I'm just kind of curious how you get to the first shippable Mercury artifact, the Magic Leap 1. How do you feel about it in those dimensions?
Well, let me give you a couple ways to benchmark it. First, me, and nothing ever satisfies me, because if you have the imagination of like the end game, like I was already not only Apollo, but we were like going interplanet. Like I could see where all of it would go. I literally would, like, to the point where I literally could see the entire thing. I know what it would be like. So when I benchmark, like, it's almost like I have to move back and forth in time. Like I could live in the 2030s and then come back and go, all right, we have to be where we are today, because we cannot force physics into the future that fast.
But how did you feel about it in time, money, results? I'm just curious if you could share, because a lot of our listeners build products and they birth them, and sometimes they come out. I'm just curious. We can skip that question and move on, because I have a bunch more.
I'll give you my and this is with time and some insight and some wisdom, right? So I could look back.
Yeah.
I look at the first thing we built that took up a room, and I see the immense system engineering and design effort to shrink so many pieces: optics, sensors, computer vision, AI. And I go, how did we pull that off? So many different, like you said, it was 10 companies worth of engineering feats.
Yeah.
And not only that, the software, we built the Lumen operating system. We scraped almost all of Android away and built like 80-90% of the code. We built the world's first volumetric web browser. We built the first AAA game in this space ever, which was Dr. Gordbort's Invaders. We made a human AI, Micah, who you could see walk around the room, stick to a room, stay around things, walk between objects. Things that are like, when we started the company, utterly and completely impossible. I had MIT, Caltech PhDs leave the company and said, you'd never make pixel stick work. You'd never make this work. You'd never make that work. Every single thing they said would not work, we made work.
That's a great, by the way, great lesson. If there's one lesson from this podcast, just hearing you say that is got to be really inspiring, because I know, again, a lot of product developers out there have a lot of experts around telling them it can't be done. And you're saying stick, one of your 100 lessons people can take from you is, even when the experts tell you it's impossible, it might still be possible.
Jon, one of the things that became incredibly difficult was, how do you get an object which is now in space not to move around with your head? How do you get it to stick to the world, which means that as you move your head pose around, you have to have what looks like zero jitter, near zero latency. How do you solve that in all kinds of rooms and all kinds of lighting conditions? And we made it work in quite a wide boundary of things. That alone would probably be a multi-billion-dollar startup.
Yeah.
In fact, one of the things that probably hurt us a little bit at Magic Leap, with so many simultaneous inventions, I'm not able to tell you the exact number, but thousands and thousands of patents. Like I'm not allowed to talk about it, but order of magnitude of number of inventions going on.
Thousands.
We actually showed up in one of the top most inventive companies in the world, like near IBM, near like one below Amazon, I think in 2018 or 2019. Like, we were, so much invention was going on. And what I was really proud of the team, because this was a team effort, not a me effort. Hundreds, brilliant of engineers. Every single thing that showed up that was hard, they solved. They had that kind of ultimate commitment to solving problem after problem after problem. And it was really tough because they're solving some of the hardest problems in the world. And then we have like some media telling us we're not doing anything at all. None of this is real. It's not existent. It was weirdly frustrating for the folks to be like working 24 hours a day to solve something. And then you made it work. And someone says like, oh, you guys are just living in the Everglades in Florida, making paper airplanes or something.
Actually, one of the things you did make, back to George Lucas, I understand there were, let's say, can you comment on any Star Wars content that was created for the Magic Leap 1?
I think there were 3 things I could comment on that were stated publicly.
Okay.
One was porgs. The porgs from I think it was episode 8 or something, or episode 7. These cute little bird things. And at one of our conferences, you could see porgs walking around. They'd sit in front of a television. They'd jump on a couch. It was actually really cute and cool. That was one. I think one of the biggest breakthrough things we had this experience where a full-scale, ultra-high resolution C-3PO and a full-scale R2-D2 looking solid are moving around in a room, recognizing tables and chairs, so they look real. And then I think R2 shoots out a Star Wars hologram like you see in the movie. So our digital, all this is happening through the device, but like the 3PO is standing next to R2. R2 throws out this kind of like Star Wars low-grade 70s hologram. So it's like our digital objects makes a pseudo hologram. That was crazy. So cool.
Yeah.
We showed it to Kathy Kennedy. Her team helped build it. It was really great. But the very best one, I'm just going to talk about it. Very best one was we did this experience we had this kind of little warehouse in the back of our factory.
Yeah, this is the one I want.
This one is just incredible. You'd walk into the room and you would see the wall, a really big wall. The whole wall would disappear. And you look out and you see the planet Hoth from Empire Strikes Back. And then you'd see us like one of those ships, like one of the speeder ships, like turn its engines on, and begin to hover in this garage room we had. Like it was big enough to contain it. And you're like, and there's a droid running around, and we had like air fans and sound, and you'd feel the thing rumble, and it would go fly out. And like these AT-AT walkers are shooting, and they're shooting inside the thing. So you feel like they're coming at you. It was like one of the coolest things ever.
Yeah. Yeah. And
we got to show that to all kinds of people at Disney. By the way, I do think like these sort of pioneering experiences will eventually make their way into LBXs, whether it's the Disneys or whatever. Like, I think they were just too compelling. But I think we were some of the first in the world to show what's possible. Like really amazing. Like here was the future, maybe 10 or 15 years ahead of where the market will be.
And I used to really enjoy. I'd occasionally visit Rony, and he'd show me under non-disclosure. In full disclosure,
saw that one, right?
I saw that one, and I was an advisor to Magic Leap. I should disclose that here, not that small participant in a big thing. But I enjoyed the visit enormously, and I still remember the Hoth experience was amazing. It was amazing to show the power of what you were building with Magic Leap 1, but also that you could marshal the resources of Lucasfilm, that you could get them to buy in to create content, a real Star Wars content officially for your platform, to me was mind-blowing. It was such a big effort. It wasn't just like porting something. It was making something cool. And you showed so many people, so many things. We're going to run out of time in today's session. We may have to have you back, but a couple of things it reminds me of. If I can fast forward, today I'm watching other people talk about the metaverse, about augmented reality and spatial sensory. What do you call it? Sensory.
I call the whole
sensory field computing.
Sensory field computing.
So we've got people like Mark Zuckerberg talking about the metaverse. How do you feel about that? Looks like there's some themes being picked up that maybe you had pioneered, and which is cool in one way. But I'm wondering how you feel about it.
I think, without breaking any NDAs, many of the people you're hearing about now probably saw what they're now talking about first through us. Mm-hmm. So I'll just leave it at that. Okay. The other thing is, not many people know this, but some do. Like Neil Stephenson, brilliant author, good friend of mine, he wrote Snow Crash. Yeah. The term metaverse is first coined and created by Neil in Snow Crash. One of the really fortunate things in my life was Neil was our chief futurist from almost the moment I started Magic Leap up until the beginning of the pandemic. And when his concept of the metaverse has been co-opted, right? It's been co-opted, and they're using the word to stick it on all kinds of things that, may or may not have anything to do with like his original imagination. In fact, when we were working together, Neil, John Gaeta, who won the Academy Award for The Matrix, and I talked about a more utopian concept than the metaverse. Because the metaverse was not that utopian. It was not really meant to be built. It was meant as a cautionary tale. So the three of us and others at Magic Leap worked on a concept that was branded to be more utopian and more thoughtful. We called it Magicverse, and we go, here's the elements of it. This is what you should build, not a more dystopian thing. You should build this other thing. Mm-hmm. We actually talked about some of the key elements like privacy and doing the right thing for people in public, because we felt like it needed to be talked about in public, and it was important for someone like Neil to be part of that, because he's like literally the inventor and the creator of the metaverse. So it was sort of our signal to the world: this is the direction, not that. Not everyone listened. But I can tell you, it's a weird thing, John, to see ideas that we were playing with that others had written about now becoming so big that one of the biggest companies in the world rebrands itself to do that. That's just mind-blowing.
Crazy. That is kind of crazy that their name is now Meta. That's pretty wild. And we're going to have to do another interview about Mako. By the way, Neil Stephenson, one last question. I'm largely talking about your work, but I have to ask. I understand Neil is actually a user of CAD or had used CAD. And do you mind saying which CAD system he used?
Neil was actually one of our super users of Onshape.
Oh, well, that's great to know. So there you have it. I would never talk about our users, but Rony is mentioning that Neil Stephenson, and I had the pleasure of meeting Neil once at Magic Leap. Thank you, Rony. It was a dinner I'll never forget.
By the way, just to push a little more, what was really great about it was, here's an author, but who also quite technical.
Yes.
But it felt like he had the tools to express himself. And Onshape was the way for him to express all kinds of ideas and designs. And it was like super exciting. It was actually great. And it was a big, you should reach out to him and get him a seat.
Yeah, well, I was so impressed because he pulled out his phone. We were at dinner. He pulled out his phone and showed me something he had made, which undoubtedly I should not mention or talk about. But it was fascinating to meet him and to discover. It was very gratifying for me to see him, Neil Stephenson of Snow Crash, using Onshape while working with you at Magic Leap. It was very cool for me. Let me turn to what you're doing now. What can you say about the new company you founded? You're CEO of Sun and Thunder. Is there anything you can tell us about it?
So here's what I'll say. If I go to the time before I started Magic Leap, I branched a lot of creative mythopia ideas away, and I just hibernated them. And I kind of worked on them at night, and I separated them and excluded them from being in Magic Leap because I felt Magic Leap would ultimately become this massive tech compute hardware thing, and those things would get crushed and lost. So I started Sun and Thunder to do a few things. One, to pick up and to keep working with Weta on those creative projects, which we've been doing for the last couple of years, and that's been amazing. We actually put out a short animated film. It won a tiny award, Sun and Thunder. But in that, I just can't help but doing this. In that, I kind of also then started asking another question about the future computing, and stumbled into an interesting idea that I won't talk about too much. But in Sun and Thunder, I created this thing called SNT Computing to be the place to think about where computing goes. And I'll say this about it, John. Magic Leap is about the hardware and computing connectivity to the human sensory system.
Okay.
But I started to ask a question about if you just live in the world of software, and then you want to look into things with all this advanced hardware one day, what will be happening? And what happens with like sentience and AI in the next couple decades, well beyond where we are today? What does that turn into? So I would say the new thing is about 80-90% software. So no more building big factories, but probably some design of silicon. So I'll say that the thing I'm doing in SNT computing has some, I would say, advanced silicon design and some really crazy software, but that makes the company different in the amount of people you need and different in the scalability. Because this, software is much more scalable than building hardware and factories and all that. So unlike Mako and Magic Leap, which are really super intense hardware, what I'm doing in Sun and Thunder Computing is very software oriented, a little bit of silicon.
Oh my gosh. Now you've got me even more excited from what little I knew you were up to. As always, it's a little hard to imagine what's in your mind, but that's always true of great visionaries. That you see things that don't exist. It sounds like you got another huge vision. I have to say our time's running out today, but I just can't thank you enough, Rony, for taking time. I know you're a very in-demand person to speak to media and other sources, so I really appreciate you talking to our audience. And I think you're someone of amazing vision and persistence, achievement, in not only the vision you have, but your ability to build things, your ability to marshal the resources of others, which is something all product developers need. And you've kept your humanity and ability to be a nice guy and a curious guy the whole way. So
that I appreciate the most. And John, and you're a really good friend. You've been a great friend and mentor for both Mako and Magic Leap, and maybe on the Sun and Thunder ride as well.
Well,
we'll work through that.
I sure hope so. So on behalf of my listeners and myself, the time's flown by, big thank you to Rony Abovitz, who's been our guest today, who talked to us a lot about his time as founder of Magic Leap and a little about it, founder of Mako. I'm hoping to get you back to talk about that and about his current work as founder and CEO of Sun and Thunder Studio. To our listeners, thank you all for tuning in. To our viewers on YouTube, thank you. You can learn more about Sun and Thunder at sunandthunderstudio.com. Right, Rony? Just Sun, it's spelled the way it is. No ampersands or anything like this. sunandthunderstudio.com. And you can listen, if you like this episode of Masters of Engineering, you can listen to other episodes or subscribe to the audio podcast at Apple Podcasts, Google Play, Spotify, or wherever you like to find your podcasts. You can also watch the new video. This is my first video episode. We're going to be putting the videos up on YouTube. I love hearing what you think, and so make sure you leave a review of this episode and tell me what you think of Rony and his story. And if you're interested in more about me, you can follow me on Twitter at @jhirschtick. Won't bother. You can see the spelling on the Masters of Engineering site. That's it for today. See you next time on Masters of Engineering.
Thank you, Jon. This was a lot of fun.
Oh, thank you, Rony. Awesome.